Hello guys, hope you all are doing very well. I was doing a simulation on Matlab, but then I decided that I need to record this simulation. So I'll be deleting all of this, or I'll just be making use of it actually, but I'll explain to you what I did previously and the simulation I am going to be running. So the simulation I'm going to be running is going to be displaying on the screen now. Look at the screen and observe the point very well. That's what we are going to be using to design this circuit. All right. So I'll be starting, but before I start, I need to identify some points. If you see, there's a point called G1 in that picture. The G1 is our generator 1. The T there means transformer. The L1 there means our load. The G2 there means our generator 2, and the other T there also means transformer equally. And our L2, L3, they are all loads. And the L in the middle of the L in the L2 and L3 is the load we are looking for. In this case, there is a student I will be working with his project. They told them that they should use the two numbers the last two numbers of their matric number to get the values of the x. I think it's x or y, I don't know, but I believe it's x. So the one we are going to be using for this experiment is going to be 79, and let's proceed. So looking at the screen, we have some blocks here which as I said before, I have already previously added. So I'll just be explaining to you what they do and what I am doing. So I'll start with the G1. For this G1, we're going to be using a three-phase source. I'm going to be using a three-phase source for this G1. So let me just shift it back so that you can see it clearly. We're going to be using a three-phase source for the G1, right? Now the next thing we are going to be doing is we're going to be reading the transformer 1. We're going to be putting a transformer 1. So we're going to be having two of these. So let me just copy it. I'm going to put it in between this. So we're going to have a transformer. Now let me just delete all of this. As I told you, we're not going to be using this. We're just using this to. Okay, now, yes, the setting of the values. Okay, for this source, let me open it and show you what I did. So I'm going to be using an 11 kV source, that is kilo voltage, and a 50 hertz frequency, right? So this is what I'm going to be, and the setting is going to be on YG. Yeah, so then the load flow still the same. Our active power generator is 10 megavolts. 10 did I say 10 MVA? 10 MVA. So this is it here. So what's next? Okay, yeah, those are the two tabs. So I press OK. Then we're going to be putting our transformer in between the generator. So let's connect it. I didn't want to make this video long, so I don't know, I will try to be fast and just pray this video won't reach up to an hour. So after the transformer, this stuff you are seeing here is called a three-phase V1 measurement. It's going to be where we are going to be reading our values on the scope. So let us connect that as well. Connect. What's next? So in between this transformer, let me push this far from me because we don't need it now. We're still coming to that. In between this, we're going to be having a load here. A load is going to be here. So we're going to be using an ROL. We're going to be using a three-phase series ROLC branch. Now to connect this three-phase array LC branch, we have a value there. We have a value of 20, um, 20 plus J80. 20 plus J80. So we're going to be calculating. The first thing we know obviously is the resistance. So we're going to put the resistance to be 20. But to get this inductance, that 20 plus, that plus that you're seeing there means that this is an inductive load. If it was a negative, it would have been a capacitive load. So this is a purely inductive load. So we're going to be calculating with x equal to xl equal to, what is the formula again? 2 pi fl. Yeah, 2 pi fl. So if we make L subject of formula, we're going to be doing x over 2 pi f. And our x here is 80. That is our inductance. No, sorry, our reactance. Pardon my grammar. You know, I'm doing this video in the night and my head is not. So we're going to be working with 80, which is our reactance. I don't know why you call it. It depends on where you are watching this video. But I believe it's reactance, right? Inductive reactance. So we're going to be saying 80 over 2 pi f. And we have our f to be 50. We're going to be doing 2 multiplied by pi, which is 3.142, or 22 over 7, depending on how you want to calculate it, multiplied by your f, in this case, which is 50. Our value should be, wait, let me punch that in the calculator. Okay, our value should be something 0.2546. So we're going to be punching that in here. Where's that? Okay, we're going to be punching that in here. So we're going to be having 0.25546. 0.2546, yeah. So I press OK. Then we're going to put in that. So let me just delete this thing. Let me be sure this is recording. Okay, it's recording. I'm trying to make this video not too long, but the way it is, I feel like it's going to be long already. So connect. So the next thing you connect is the transformer. This is the transformer. Okay, I haven't showed you about the transformer. Okay, let me open the transformer for you and show you what I connected. So the transformer is going to be a still YG, right? And it's a three-phase transformer. So let me open this. Okay. So my transformer is a 10 mega voltage transformer, and it has a frequency of 50. So this is 50. What's next? Then our voltage, this is a step down transformer. It's stepping down the voltage from 11 kV to 415 kV, and 415 kV. I think it should just be 415. Wait, let me delete this. Oh, so okay, that is point. Okay, sorry, that is point. So yeah, it's correct. So that is 415. It's still the same thing. If I take off that point, that 0 point there, it will still be the same thing I'll have. So yeah. So let me set that. Let me also set 50 here as well. So let's go into this place. Set it to be 50. 50. So we press OK. So I connect it. So what I'm connecting now is the three-phase to the transformer. So what next? So then our G2. So let me just copy this. Okay, let me bring this one closer because we're going to read there. This is going to be our G2. So this is our G2. Just paste it here. Let me flip this. Okay, so we'll flip it. So flipping that gives us this. So let me just delete this. Okay, no, not deleting. Okay, yeah, let me delete everything here. So flipping that gives us this. What next? So yes, the next thing now is to do the denominator side, and we have some load there. So let me just copy this. We're going to be needing three of them down there. So the first one, second one, and the third one. This one, this second, this L2 and this L3, they are not the same because the values are different. So let me check the values. So the value is 10 plus 40. So it's the same thing. So we put 10 and we divide 40 over 2 pi f. So let's go. So this one is 10. We start with 10. 40 over 2 pi f should give us, bring out your calculator, it should give us 0.1273. 0.1273. Alright. Okay, sorry, I supposed to put this capacitor as infinity. Since this is a purely, I guess you must have figured that out. If you've not, no problem. So, but for this one, we're going to do a separate calculation for that. Just chill on that first. We're going to do a separate calculation on that. So it's going to be INF. It's going to be 0 point what again? 1273. One, two, 7, 3. What will it to be 10? First, okay. So the way this was connected was it was connected before the transformer. So let's connect A to A, connect B to B, connect C to C. Now, okay. Now to connect these faults. Okay, the first one we had, they didn't ask for fault, so we just run it at normal condition. This one should be after the G, so A to A, B to B, C to C. So to set up the middle one, which is quite more long than the rest, we're going to calculate it this way. We're going to use the formula S equal to square root P square plus Q square, where P square is 10 squared plus 79 squared. When you get your answer, you get a value for your S. After you've gotten your value for your S, which is your apparent power, I believe. But let me find out the exact formula, and I'll paste it here so that you can also use it to solve. Okay, yes, that should be 79.69 MVA. After you've gotten that, you then need to get your voltage, your line voltage, and your line voltage is 33. If you do 33 divided by square root 3, you should be getting 19052. That is your line voltage. You're going to be using that. We're going to be using that line voltage now in a bit. So remember, if you do arrow, which is your resistance, you can do. Remember, I don't know if you remember this formula. V is equal to IR squared. Do you remember that? Okay. Do you remember V equals to? Sorry. Do you remember arrow? I need to sleep. Do you remember arrow equal to V squared over P? Do you remember that formula? Yeah, we're going to be using that formula. Arrow is equal to V squared over P. So we are going to be saying now our P in this case is, let me find it so that I'll not lead some people astray. It's 3.33 multiplied by 10 raised to power 6. That should be basically 33 something, 33 kV or something of that nature, right? So let's multiply. So that arrow that we're getting is our resistance per phase. Resistance per phase. Remember the voltage. Okay, I think I'll just paste it. I'll just put something that you can all view it. Now the next thing you need to get is your XL. Your XL. Remember our formula. Remember the main formula that we're looking for. We're just looking for arrow and we're looking for L. We've gotten arrow now, then L. And L, to get L, you do L equals to XL over 2 pi F. Do you remember that? Alright, so let's proceed. So our XL should be the voltage you just had, all squared it, divided by 79 e raised to power 3. That should give us 13.73 per phase. Why our L? Our L value is 0.0437 Henry per phase. Don't know what about that. I will just post it so that you all can see it. I'm just making the video now. I will just explain it. So our R, let us start from that. Our R should be, what did I say our R is just now? Alright. Okay, that is 108.9. Our R is 108.9. So we say 108.9. Then our L should be 0.0 something. Let me find it. Let me calculate that. 0.0437. 0.0437. 437. So our capacitance is INF, which is infinity, and pressure. Okay, so we'll just run this. Once we run it, okay, let us get, okay, now power, sorry, we need to get power. And to get power, we need to make this, we need to set it to accept 3. How do I set this thing again, Lord? Wait first. Okay, yeah. So we say 3. It's taking me time. Okay, sorry. Okay, this is it. Your number of output 3. I've even opened it. So we say apply. So that is 3. So now, but let me check if okay, it is now 3. Okay, all right. So this, you put your V, you take it to your V, and you take it to your I. Then you put the output. The output should be P, not Q. Q is your apparent. No, sorry, not your apparent. Yeah, alright. So let me also do this here. So let me just copy it. Paste this here. Let me also do the same thing here. I'll do the same thing here. Put the number of output to be 3. Set it, okay. Then put the view as well. Put the view layout to be 3 boxes as well. And delete it. So we say V and I. So we run it. I set my stop time to be 0.5 seconds, so we'll see our this running might be what will take time. Let me check how many minutes this video have been. Is there a way to see this? Okay, I don't think I can see it now. Maybe okay, 19 minutes, okay. Alright. Okay. Let us wait. I believe laptop has successfully paused. This one is not hanging, this one is pausing. So let's wait for it to unpause. I believe it's ready now. Let us see. Okay, yeah, it is ready. So you see the first. Okay, let me increase it. So this is the normal working condition. You can see the voltage just spiraling down from this point down to the negative point. You can see even the current spiraling down from something around 2,800 to negative 2,000, and the power as well. You can see the thing started up at 7.3. This is it multiplied by 10 to the power 5, and it's gradually stabilized. So this is for normal working condition. Then yes, for fault condition, for fault we just bring in fault. We say three phase faults. Now these three phase faults, remember in electrical you have three phase. So these are the first phase, second phase, third phase, and ground. If you're working with three phase fault, you will do 1, 2, 3 all connected with the ground. If you're working with one phase fault, you would uncheck this box. Uncheck all this box, it will not be a single line to ground fault. So that's just basically what we need to do. I think I need to make this. I'm coming. There's a setting I do set here, but let me see. I was trying to get it to chill until I've gotten it. Once I've gotten it, I will then tell you what to do or what I did. Did I get it? Did I get it? What I just want. Okay, let me see if it worked. Okay, yeah, it worked. So yes. So the first one says we should connect our ground fault at G1. I believe I can't see the question now. But let me check. Wait. So I'm coming on. I'm trying to look at the text where I got it from. You know, you all, I can just paste on the screen. Me, I can't paste it on the screen now because I'm not looking at it, but I should be looking at it. So in 5, 4, 3, 2, 1. Okay, they say okay, fault condition. Now three phase bolted fault at generator G2 terminal. So this is the generator, this is the G2 terminal. So to just do it, you just put our first phase, second phase, and our third phase. So with this, I'll just run it. Let me see if it is okay. Yeah, there is all the phases. So I will run it. I don't know if it's already on a bit. I was run a bit too. No, it has no. Where's my laptop? Okay, it's compiling. We're going. Okay. So let me. Okay, so this. Wait. Okay, yes, that's come. Sorry. Okay, ready now. Okay, so this is it. This is the first fault we have. You can see how it is. It went from here, then it stopped. This was when the thing picked up. It picked up at 0.1. You can see the fault there. Now, also if you come to G1, you will see almost the same thing. You can see almost the same thing. So that's basically it, guys. Yeah. I'll be posting more of these videos as I'm being tasked to do. So enjoy yourselves and have an excellent day, all of you.